Hello everyone. In this chapter, we begin exploring motion. So, motion is something you experience every day. Cars driving, balls rolling, or even you walking across a room. So, take a moment to think what's the first example of motion that comes to your mind? Now, here's a quick question for you. Which branch of physics deals with motion? The answer is mechanics. So, in this chapter, you will learn how to describe motion clearly using concepts like position, distance, displacement, speed, velocity, and acceleration. So, we will also see how graphs and equations help us tell the story of motion. So, by the end, you will have the tools to describe how things move, just like a physicist. So, by the end of this chapter, you will be able to describe motion clearly and precisely in your own words, explain the difference between speed, velocity, and acceleration, and use graphs to tell the story of motion. And here is our roadmap for this chapter. So, we will start with the speed, first average speed, then instantaneous speed, because that's the simplest way to describe motion. And once we understand speed, we will move on to velocity, where direction becomes important. From there, we will talk about what happens when motion changes, and that's acceleration. So, to make sense of all of this, we will learn how to graph motion, because graphs help us actually see the patterns. And finally, we will focus on a very common case, uniform acceleration, like objects in free fall. So this will bring us to equations we can use to predict motion. Now, we all have some experience with driving or riding in a car, right? So quick question. Have you ever looked at the speedometer while riding or driving? What did it say? So if you want to describe how fast you are moving, you are talking about speed. So let me ask you, if the speedometer reads 60 mph, what does that really mean? Pause for a moment and think. So it means we are covering 60 miles in 1 hour. So speed is always some distance divided by some time. Now think of your last trip. How far did you go and how long did it take? So that's basically the average speed calculation. So the average speed is equal to the total distance traveled divided by the total time of travel. And let's write it symbolically. It's S equal d over t. S is speed, t is distance, and t is time. So using symbols make it easier to remember and apply in problems. And the standard unit of speed is meters per second, m over s. But in day-to-day life, we often use miles per hour, mph, or kilometers per hour, km over h. So now that we know how to calculate average speed using s equals d over t and understand the units, let's try a simple example together to see it in action. Now grab a piece of paper and let's solve it step by step. So let's practice converting units. Now here's the question. Convert 70 km per hour into miles per hour, mph, and meters per second. So I'll give you a moment to try this on your own. Now pause the video and give it a try. Remember, for part A, to convert miles to per hour, use the conversion factor 1 kilometer is equal to 0.6214 miles. Now, part 1, you have to change the unit kilometer into miles. That's it, right? So we know that 1 kilometer is 0.6214 miles. So now you can write that as a fraction. You can write that as a fraction so that the unwanted unit here, kilometer, would cancel out and you will get the unit miles per hour. So that you have to multiply 70 by 0.6214. So you will get 43.5 miles per hour or mph. And next, the second part. So here you have to change kilometers to meters and hours to seconds, right? So you have to change both units. First, let's change the unit of kilometer to meters. So we know that 1 kilometer is 1000 meter. So we write that fraction so that kilometer unit cancels out and the unit meter remains in the final answer. Now you have to change the unit hour into seconds. For that, first let's convert the unit hour into minutes. And we know that 1 hour is 60 minutes. So you can write that fraction so that hour will cancel out and you will get the unit in minutes. Now again we have to change the unit minute into second. And we know that 1 minute is 60 seconds. So you can use it as a fraction so that minute unit will cancel out and you will get the unit in second. So if in the final answer, the final unit is meters per second. Therefore, the final answer is 70 kilometer per hour is equal to 19.4 meters per second, right? Now let's try another example. So this image shows a road map for a trip from Kingman to Phoenix going through Flagstaff. So you are given the distance and travel time for each segment, Kingman to Flagstaff and Flagstaff to Phoenix. And now your task is to calculate the average speed for the entire trip. Now remember the formula. Average speed is total distance over total time. Now again, you can pause this video and you can try to solve the problem by yourself. Okay. So first we find the total distance. So the distance from Kingman to Flagstaff plus distance from Flagstaff to Phoenix, right? So that is from Kingman to Flagstaff it is 120 miles and from Flagstaff to Phoenix it is 140 miles. So the total distance travel is 120 plus 140 which is 260 miles. Next, the total time traveled. So from Kingman to Flagstaff it takes 2.4 hours. And then from Flagstaff to Phoenix it takes 2.6 hours. Therefore the total time is 2.4 plus 2.6 hours which is 5 hours. Now you know the total distance and the total time. So to find average speed you can divide the total distance over total time. 260 miles divided by 5 hours. So the answer is 52 miles per hour, 52 mph. Right? So the average speed for the whole trip is 52 mph. Now take a moment to check your calculation and make sure you understand each step before moving on. Now that we have learned about average speed, let's talk about another important concept. Instantaneous speed. So think back our last example. The trip from Kingman to Phoenix. If we say the average speed was 52 miles per hour, does that mean the car was moving exactly 52 miles per hour the whole time? Of course not. The speed goes up and down when you accelerate, brake or overtake other cars. So the speed at a specific moment in time is called instantaneous speed. So this is what your car's speedometer shows. So it tells you how fast you are going right now at the very instant. And we can also calculate instantaneous speed by finding the average speed over a very short time interval, small enough to approximate the speed at that moment. So take a moment to think. Next time you look at the speedometer, that number is the instantaneous speed, not the average over your whole trip. Now again, let's look at an everyday example. So which speed do you think the highway patrol is more interested in? Average speed or instantaneous speed? Now take a moment and think about it. Can you guess the answer? So police officers uses a radar gun to measure your speed at a specific moment in time. So the speed limit shows the maximum legal instantaneous speed, not your average speed over a trip. So the answer is instantaneous speed. Now that concludes section 1 of chapter 2, where we learn about speed, including average and instantaneous speed. So in the next sections, we will move on to velocity and acceleration and see how they help us describe motion even more completely.